Hello everyone, this is for section 12.1 for pre-calc. Trying to get you guys a little more used to doing limits. Here you're asked to find the limit as x goes to 3. Sometimes you can just take that number and fill it in. So you get 4 times 3 minus 2, which is 12 minus 2, which is 10. So sometimes you can do direct substitution, fill it in, and get an answer. Sometimes you can't. If I asked you to take the limit of this function as x goes to 2, by filling in the 2, you guys can see you get 3 over 0. So this doesn't tell you any information. It's not good enough. So you have to look at your table to see if it's going to help you decide what to do. So you type the equation in like you're going to graph it. You hit second window to be able to adjust your table. Because I'm taking the limit at a specific value, I need to see as it converges from the left and the right. Say this is a number line, and there's the value of 2. As you come at it from the left and the right, what are the y values doing? I need to take little tiny steps away, like how about 2.01, 2.02, 2.03, and likewise go backwards. 1.99, 1.98, and so on. So I need to create like a table of values and look and see if the y values converge as you approach. Oops, I suppose the value of 2 needed to be stuck in there. The value of 2. Okay? So that's what happened here. I told it to do that. I tell it to display it. And at 2, there's an error, which is what we got right here. Are you converging? Are you getting closer and closer to the same number as you come at it from the right and from the left? Okay, this is the left side. If you were to take this and lay it on its side, 1.97 is over here, 1.98, and so on. And like 2.01, 2.02, and so on. So this side is from the right, this side is from the left. Are they converging to the same number? No, they're not. Even if these were positive, or even if these were negative, infinity is not an answer. Now look at the graph. As you come at it from the left, your graph is going down to negative infinity. As you come at it from the right, your graph is going up to positive infinity. So there is no limit. It is divergent. It diverges at 2. Okay, try this one. What's the limit as x goes to 0? So try filling in a 0. All right. So you get 0 over the square root of 0 plus 1 minus 1. So that's 0 over the square root of 1 minus 1, which is 0 over 1 minus 1, which is 0 over 0. Whenever you guys get 0 over 0, it's called an indeterminate form. It doesn't tell you anything. It's not determinate. It's indeterminate. So you do the same thing, plug it in. This time I want to start my table at 0 rather than starting my table at 2. And that meshed with, that jived with where you're taking the limit. This was the limit at 2, so I had to tell it to start at 2. This is taking the limit at 0, so I need to tell it to start at 0. I'm going to take little steps either way. Does it look like these are converging to the same number? To me it does. It looks like it's converging to 2. So 2 would be your limit. Even though at 0 it doesn't exist. It's getting closer and closer to 2 as you come at it from both sides. Alright? Let's try graphing this one. You're graphing y is equal to 2 and y is equal to 0. Alright? For anything other than 3, when your x value is anything other than 3, you get a horizontal line at 2. That's what this says. Okay? But when it is 3, you get a value of 0. So at 3, there's a hole, and the value is there. That's what this graph is going to look like. What is the limit as x goes to 3? Well, as you come at it from this side and come at it from this side, what do your y values approach? They approach 2. Even though it doesn't exist at 3 for a value of 2, it's 0. Even though So if you were to take the function and go f of 3, you're going to get 0, because that's what it's worth. But the limit, as you approach from left to right, as you're getting closer and closer and closer and closer, well, you're always R2, and then you're 2, right up to that sucker, infinitely close to that sucker. It's 2. The limit is 2, right? All right, let's try this one. So you got y is equal to 2, and y is equal to 4, the two things you're graphing. Looks like garbage. Let me get rid of it. There's a boundary line at 3. The limit as x goes to 3, sorry, let me graph this. Y is 2, y is equal to 2, for anything greater than or equal to 3. So that's this, closed circle. Less than 3, it's a value of 4. So there's 4, open circle. So this is your graph. What is the limit as x goes to 3? Well, as you come at it from the left, you get 4. As you come at it from the right, you're getting 2. So these are not the same number at that value, so there is no limit, because they aren't converging to the same number. Now, just to change it up, if I asked you for -3, what's the limit as you approach -3 from both sides? Well, then it's 4. Okay, it has to be the same number from both sides. So there's no limit for this one. Okay, how about this? Evaluate it 1 over 0 squared. You get 1 over 0. Doesn't help. When you graph this, there's going to be a vertical asymptote at 0. It's an inverse square graph, so it's sitting here and here. If you set up your table to look at it, you start your table at 0, and you take little steps away from it, what you would see on your table is that they're converging to positive infinity, but positive infinity can't be an answer. It needs to be a concrete number like 5 or 7 or -2. Okay, so there is no limit for this one. That should be all the information you guys need. Here's your assignment for section 12.1.